How are you, my friends? This is lecture number 17 of the Calculus 1 lectures, the first derivative test, and we will see some applications. In the objectives of this lecture, we will look at absolute and local maximum and minimum values. There are 4 examples there, simple examples, and then we will look at other questions where we study the first derivative test. And then we will look at optimization, where we maximize or minimize some quantities. The first derivative test for local extrema. If we have a function continuous on an interval, differentiable also there, we can find the critical values, critical numbers, as we did before, and we study the derivative of the function. If f prime of x less than 0 to the left of the c, we have seen some examples there, and f prime of x is greater than 0 to the right of the c, then at c we have local minimum. So this is negative and then positive, so there's a local minimum. If the opposite occurs here, we have a local maximum. If there is no change in the sign of f prime, remember we are studying in the table of signs f prime, there is no change in the sign, then we have neither a max nor a min. Now this slide is from lecture number 10. This is math English terminology. I have explained the word local maximum, relative maximum, etc., local minimum, extremum, extrema, absolute max, absolute min. You can read this, maxima, minima. You can go to lecture number 10 and you see this in details. Let's look at example number 1 here. Find and classify the critical points of this function f of x equals 2x cubed minus 3x squared minus 36x plus 7. To classify the critical points, we have to find the derivative of the function. This is easy, polynomial function. The derivative will be 6x squared minus 6x minus 36. And then you can take 6 common factor. You factor inside the trinomial x plus 2, x minus 3. Now the critical points, they occur when f prime is equal to 0. So when x is equal to minus 2 or x equals to 3. So these values, they separate the x-axis into open intervals from minus infinity to minus 2 to 3, 3 to infinity. So these are the critical numbers. Now we have to study f prime as we did before using table of signs. I mentioned many times this table of signs. If you need to see more examples, you can go to lecture number 25 of the algebra course. So we write here x plus 2, x minus 3. This is f prime. Remember, we are studying here f prime. So just choose a number here, test point, between each in the interval. And then we see here f prime is increasing. See, this is the first derivative test. F prime is increasing, f prime here decreasing. So we have a local maximum there at minus 2. If you need the maximum, you put minus 2 in the function. See, f has a local maximum at minus 2. Now, f prime is negative here. F prime is positive there, so there's minimum here. So f has a local minimum at 3. To find the minimum value, the minimum equals f of 3. Replace 3 in the function itself. Now, the first derivative test for global extrema. Global means the absolute. So when do we have absolute? One absolute minimum and then absolute maximum. This is global extrema. Absolute minimum, if this value is the minimum value in the whole domain, in the whole interval, there is no other value less than that. And the absolute maximum is the same. Absolute maximum means the highest value in that interval I. We can see now many examples on this. Given this graph here, f of x is equal to ln of x divided by x, defined on the open interval from 0 to infinity. Why from 0 to infinity? That's a positive because the argument here in any logarithmic function, this is logarithmic function of base e, ln of x. 2 ln of x divided by x, so the domain should be from 0 open to infinity. Find local absolute extrema. Now to find the derivative of this function, the given function 2 ln of x divided by x, you can use directly the quotient rule. This is u, 2 ln of x divided by v. You can do that. Use the formula for the quotient rule, u prime v minus v prime u divided by v squared. You will get the same derivative. But I did here something just to give you an idea that you can make this 2 over x times ln of x. That's the same as the function f. Just I wrote it in another way. So that I can use the product rule, u prime v plus v prime u. This is from lecture number 7. So you can do it in the product if you do it this way, my way, or you can use the quotient, you will get the same derivative. So here I will take the derivative of 2 over x prime here, prime of 2 over x, ln of x plus ln of x prime divided by 2 over x. So you do that simply, you get 2 over x squared times 1 minus ln of x. So the critical point is at x equals e. Why? Take this one is equal to 0. So ln of x is equal to 1. So ln of e is equal to 1 also. So x will be only e. Now f prime is positive. That means all this should be positive. 1 minus ln of x. So this one becomes less than 1. So x less than e. If f prime is negative, so you take all this, 1 minus ln of x negative, take this on the other side, ln of x is greater than 0, so x greater than e. From the first derivative test, we see that you replace e in the function here, so 2 ln of e divided by e. So f of e will be 2 times 1 over e, which is 2 over e. This is local maxima. See? F is increasing. Remember, f is increasing always if f prime is positive. So x less than e, but it should be positive from 0 to infinity. So x between 0 and e. See, from 0 to e, the function is increasing. Decreasing if f prime is less than 0, which is x greater than e. So it will be from e to infinity. Since we have the only critical value is x equals e, so this is an absolute maximum or global. So this is the maximum value. There is no other maximum value between 0 and infinity. Okay. Now find the absolute minimum value of this function f of x, x plus 4 over x. X between 0 to infinity. So first we have to do the derivative. Okay, so this is f, the function, x plus 4 over x. This is so easy to find the derivative. Derivative of x will be 1. The derivative of 4 over x will be minus 4 over x squared. Find the LCD there, so it will be x squared minus 4 divided by x squared. Now put the derivative is equal to 0, it will give x squared minus 4 is equal to 0, so x will be minus 2, and x will be 2. Minus 2 is not in the open interval 0 to infinity, which means not in the domain of this given here. So we need only this part, you see? This part. So the only critical number is x equals 2 to consider. So we can make table of signs to study f prime. Remember, always table of signs to study f prime. So we have a 2 from 0 to 2, 2 to infinity. We have f prime here. Just here, x squared minus 4. Take any number, let's say 1 between 0 and 2. Put it there, it will be all negative. Greater than 2, it will be positive. So f prime here, negative. You see f prime negative from 0 to 2. So f decreasing, f prime positive. So f increasing. So there is a local minimum, and it's also an absolute minimum at x equals 2. Put 2 in the function, so it will be f of 2 is equal to 4, because this is 2 plus 4 over 2. So it will be 4. So 4 is the local minimum and the absolute minimum in this interval from 0 to infinity. Now these are absolute versus local maximum and minimum values. 4 simple examples. You can just read it at your leisure time. Here we have local minimum at 0, 3. See the minimum here. Same as the global minimum or absolute. Global the same as absolute. See, sometimes we have local minimum and the global minimum is the same. Look here, we have local maximum at 1 and 4. Same as the global. This is the absolute maximum. Here we have local minimum. See, this is a local minimum at 3 minus 27. It is not the global minimum because this graph will go down here to minus infinity. This is local maximum at minus 1 and 5. Local. Local means relative. But it is not global maximum. So not always the local minimum or local maximum is the global or the absolute. Look at this strange here, example D. Critical point at 0, 2 here, see? See this function y equals x cubed plus 2. You can try it yourself if you like. Find the derivative, all this. So the critical point is 0, 2. So this graph has neither global nor local. So there is no local max, no local min, no global max, no global min of this function, because this function will go up to plus infinity, it will go down to minus infinity, and we have a number here where the derivative is 0. Optimization. Optimization actually is an important, really important topic in this course. Everywhere we look in business and industry today, so they study things to minimize the cost, minimize the time, minimize the energy, or they would like to maximize productivity, maximize profit, maximize the benefits. So here where calculus comes. So these are word problems. You have to read them carefully, draw a sketch sometimes, determine the variables, decide the quantity to be minimized or maximized, use the first derivative test also. Now we have seen this example or similar in lecture number 1, but we did not discuss the minimizing and maximizing. It was only establishing the function. Remember that. Now let's look at the question now. A company wants to manufacture a cylindrical can, just a can here like this, with the volume 125-inch cube by cutting its top and bottom from squares of metals. If we need this top circle and the bottom circle here, we have to use squares of metal, square, and then we cut circle from the square and forming its curved side here from a rectangular sheet of metal to match its ends. What radius r? We have here to find the r, and we have to find the height h of the can that will minimize. See, all these optimization questions, you will see the word minimize or maximize. That will minimize the total amount of material used in the rectangle and the two squares. Okay, now this is a little sketch here. So this can, we have to manufacture, we have to make it. And we have here squares. You see this square? We will cut the circle of the bottom here, and then we will throw away these pieces. And then from another square, we cut a circle for the top. Now look at this sides here. We have to have a rectangle here, big rectangle. This one here, the length of the rectangle will be the circumference, 2 pi r. And this width, this is the width of the rectangle, will be the height h. So this is the curved side. Now the area will be the area of the top circle, the area of the bottom, and then the area of the side. But before we use the circle, we have to use the square because this is the material used. 2r times 2r for the top, 2r times 2r, this is the length times the width. This is a square, so it will be considered as a rectangle, plus the area of this will be length times width will be 2 pi r times h. Let's call this equation E. So here we have h, we have r, two variables there. So we know the volume of the can will be the area of the base times the height. So it will be 125 given this one equal pi r squared times h. So h can be 125 divided by pi r squared. This is equation star. Substitute equation star in E, we will get the function area A of r. So this is like a normal function, f of x. It will be 8 r squared plus 250 divided by r. When you cancel the pi, cancel the r, multiply 2 times 125. So this will be the function. Now we need to minimize. Then we have to use the first derivative test. So we take the function a of r, and we continue find a prime. So it will be 16r. 250 over r, the derivative will be minus 250 divided by r squared. So let a prime is equal to 0. This is the derivative here of the function we have found. So a prime will be 0. Put 16r minus 250 over r squared is equal to 0 and solve for r any way you like. You can take this on the other side. You can cross multiply, divide by 2. Whatever you do, you will reach r cubed is equal to 125 divided by 8. Take the cube root now both sides. See here, r equal the cube root of 125 over 8. So it will be 5 over 2, simple number, 2.5 inches. So what is this? This is the critical value. This is like the value for the x in the other functions. R is 2.5. So we need h. H will be 125 divided by pi r squared. So you put r there, 20 over pi. This is a good answer. But if you need the exact answer, you find it by calculator. 20 divided by pi will be approximately 6.37 inches. So this is the r and this is the h. These values for the radius and the height that will minimize the amount of the material used. Let's say another one, an open-topped rectangular box with a square base. So we have a box here, open from the top here. It's open, you see, you can see that easily. It has the volume of 500 centimeter cube. Also, we have seen this example in one of the Calculus 1 solved questions, but half of it, not complete. It was only establishing the function. Now we need to study. Find the dimensions, the x and the y, that will minimize the total area A of its base and the four sides. So we need the dimensions, we need x and y that will minimize the total area of the base and the four sides. So directly we can write T, let's say, let T be the total area of the base and the four sides. The base here will be x and x, so when you find the area, x squared. The four sides, you have one side, two sides, three sides, four sides. Each area will be x times y, so you multiply that by 4. Now the volume of this box, it will be the area of the base times the height. It was given 500 is equal x squared. This is the area of the base times y, the height. So y will be 500 over x squared. Replace now equation 2 in equation 1. You will get this function t of x. It will be x squared plus 2000 divided by x. Let's find the derivative now. Yes. This is what we need here. So the derivative t prime of x will be 2x minus 2000 divided by x squared. Let t prime is equal to 0. Take all this, the derivative 2x minus 2000 over x squared is equal to 0. Simplify. Take this on the other side, cross multiply. You get x cubed is equal 1000. So here we need x. The critical value, x will be 10. Now, if x is less than 10, just take any number x less than 10, and it should be for sure greater than 0. Let's take 1. So here you place it there. 2 times 1 minus 2000 divided by 1. So t prime will be negative. So t prime is negative. That means the function is decreasing function t. If x is greater than 10, you can take 50 or 100, then t prime will be positive. You are studying now t prime here, but there is no need for table of signs. It's not complicated. Now, by the first derivative test, we find t of 10. 10 is the only critical value. So t of 10, we replace 10 in the function t. 10 squared plus 2000 divided by 10, it will be 300. So this is the absolute minimum. Now, the conclusion, we need the dimensions that will minimize the area T. We need X and Y. X will be 10 from here, 10 centimeters, and Y will be 5 centimeters. Just take X is equal to 10 in the Y equation 2. 500 divided by 10 squared, you get the Y. So the dimensions are X equals 10 centimeters and Y equals 5 centimeters. Now, please always check the playlist for other solved questions, Calculus 1 solved questions, to understand the lectures better. This is the end of lecture number 17. Thank you for watching. If you like the video, you can subscribe and share it with your friends. I hope I can see you in another video with another topic. Thank you guys for listening.